Example, very near, at that time cohesive forces will be more. Whenever they are far away from each other, at that time what happens? Nothing but cohesive force will decreases. Distance is increasing, cohesive forces will decreases. Attraction force will decrease, right, whenever we are moving away from each other. Now, whenever the velocity difference is increasing, at that time what happens? Nothing but cohesive force also increasing. Then Fv is directly proportional to dv by dy we got. This is the known as what? What is this known as? Velocity gradient. Anything divided by the distance is anything is gradient only. Now together what I can write? Nothing but Fv is directly proportional to a into dy by dt. Here what is the constant will come? Coefficient of viscosity neta, that is a into dv by dy. Now this coefficient of viscosity, units are important for this. This coefficient of viscosity neta is equals to what I can write here? Fv by a into dv by dt. Either I can take it as a pressure. For remembering you can take it as a pressure, but this force is which force? That is viscous force. Actually pressure nothing but we should get which type of force? Normal force we have to get. But this is a viscous force. You can remember as a pressure, but you cannot write as a pressure this one. So here neta is equals to force by area into dv by dy. I want to get the units of this. How to get the units of this? Force is here what? Newton divided by area means what? Meter square. Velocity means dv means velocity, meters per second, and then this is again distance only. Then mm gets cancelled here. Then what I can write this one as? Newton second per meter square. What is the Newton per meter square means? Pressure units, Pascal, right? Pascal you have to take. Pascal, then this one is what? Yes, is a second. Pascal second is a unit of the coefficient of viscosity. And this Pascal second we cannot get always in Pascal second, they will tell in the Poiseuille. So that Pascal second is known as a Poiseuille here. Poiseuille. Poiseuille. So what is a Poiseuille means? The unit of the coefficient of viscosity. The unit of coefficient of viscosity is what? Poiseuille here. And that Poiseuille values will changes. How it will changes? Nothing but here I want to get this one in the CGS units. How can I get? Newton second per meter square is there. Now I want to get in CGS. Newton nothing but what? How much I can write? 10 power 5 dynes I can write. So 1 Newton is equals to 10 power 5 dynes. Then second is second only, that divided by meter nothing but how much I can take? 100 centimeter. Meter square is there means how much I can take? 10 power 4 centimeter square. You understand properly? 1 Newton is equals to 10 power 5 dynes. Okay, then second is equals to second only. 1 meter is equals to how many centimeters? 100 centimeters. Now meter square is there nothing but 100 into 100, 10 power 4 we will get. Now 10 power 4 and then 10 power 5 gets cancelled. Then what is remaining here? 10 dyne second per centimeter square. So this dyne second per centimeter square nothing but that is again CGS unit of the, what is that? We got coefficient of viscosity here. So CGS unit of viscosity is what means? That is 10, we call it as poise. So here 1 Poiseuille nothing but how much we got? 1 Poiseuille is equals to how many poise we got? 10 poise. We got, first of all listen here, neta is a coefficient of viscosity. Neta formula already we got that. Why? Because the viscous force is directly proportional to the area and the viscous force is directly proportional to the velocity gradient we got. Whenever I remove the proportionality, then we got it as neta. Neta is what here? Coefficient of viscosity. That coefficient of viscosity units I have to get to know. For that purpose, neta is equals to Fv by A into dV by dy. Now this coefficient of viscosity is this is a frictional force, no, viscous force, right? Viscous force means again newtons, area means meter square, and then this is dV means what? Velocity. Velocity is what? Meter per second divided by distance again, that is divided by meter. Meter gets cancelled, second will go up, so that Newton second per meter square. Newton per meter square nothing but what? Pascal only, right? Pressure units are what? Pascal. So Newton per meter square I got 1 Pascal and then second as it is. This is known as what? Poiseuille. The actual units of the coefficient of viscosity is Poiseuille. That Poiseuille, how it came, nothing but this is how it came. Pascal second is known as a Poiseuille. So that Poiseuille value you have to convert into CGS units. You have to convert into poise. For that purpose, I can write this one only, Newton second per meter square means what I can write here? Poiseuille I can write. So that is a Poiseuille or Pascal second. Poiseuille or Pascal second is equals to Poiseuille or Pascal second is what? Newton second per meter square. Newton nothing but how many dynes? 10 power 5 dynes, already you know that. Second, and then meter nothing but meter square means 10 power 4 centimeter square. Now we got how much? Nothing but 10 dyne second per centimeter square. This dyne second per centimeter square is known as what? Means poise. So 1 Poiseuille is equals to 10 poise, I can say. So here that is 1 Poiseuille. The units will be confusing for you, just remember properly. 1 Poiseuille is equals to 10 poise. Can I say that this 10 means deca? 10 is known as what? Deca only, right? So that what I can say, nothing but 1 poise is equals to deca poise. You understand the units, right? So here 1 Poiseuille is equals to how many we got? 10 poise we got. Instead of 10, what I can write? Deca I can write, right? 10 nothing but deca, 100 means centi, you have to take that as so that, and then 1000 means kilo, you have to take like that, you know already. 10 power 6 means how much I have to take? Mega, and then giga, like that you will get. So here in the same way 1 Poiseuille is equals to I have proved as 10 poise. Instead of 10, what I can write? Nothing but that is another deca poise I can take. Just in the place of 10 I have written the deca, that's it. So here 1 Poiseuille, otherwise 1 Pascal second is equals to 1 deca poise. Clear? That is the units of the coefficient of viscosity. Can you tell me the dimensions then? Dimensions. Newton second per meter square means what is the dimensions? Newton means what? ml t power minus 2 t that divided by L square. Then what will get here? ml minus 1 t minus 1. Pascal second, right? Pascal means ml minus 1 t power minus 2 we will get. Into second nothing but t power minus 1 you will get. This is a dimensions of coefficient of viscosity. Copy everything. I think units I did not discuss yesterday. Finish all the units? Done. Next, the temperature dependency of the viscosity. So the main units they will give either in terms of poise or Poiseuille. Okay na? 1 Poiseuille means how many poise? 10 poise or 1 deca poise you can say. anything. Pascal second is also known as a Poiseuille here, and the dimensional formula we got. The main thing is, whenever you say the coefficient of viscosity, the main units are Pascal second or Poiseuille, both are same only. So 1 Poiseuille is equals to how much? Nothing but 10 poise. 10 poise I can say, even I can say it as a 1 decapoise. Otherwise 1 Pascal second is equals to 1 decapoise. Everything is same only. That is about the units. And also now temperature dependency on the viscosity. In fluids it will be separate, and in the solids in the gases it will be separate. So in case of liquids, I said viscous force is due to which forces? Cohesive forces between the water molecules, otherwise fluid molecules. That is due to in the liquids. In case of gases, what happens means, listen properly, that will be based on the kinetic theory. Whenever you are raising the temperature, at that time what happens? Kinetic energy will increases, number of collisions also increases. Here number of collisions, nothing but in the liquids I said that this is viscous force is due to the cohesive forces between the water molecules. In the case of gases, the viscous force is due to the collisions, of the gas molecules. In case of liquids it will be different, in case of gases it will be different. In liquids due to the cohesive forces. In gases the viscous force is due to which forces? Collision force, nothing but exchange of momentum. Whenever I raise the temperature, they will gain the thermal energy. By that thermal energy what will increases? Kinetic energy increases, and then they will be moving with very randomly with high velocity. At that time what happens means number of collisions will happen. Whenever the number of collisions are happening, I said the collision definition itself. What is the collision? Nothing but a strong physical interaction by which bodies will exchange the momentum. Whenever I collide this hand with this hand, at that time the momentum of this hand gone to this one, the momentum of this hand gone to this one. Understand? So that is a collision. Basic meaning of the collision is collision nothing but a strong physical interaction between the bodies. By that what happens? Bodies will exchange the momentum. In the same way, in case of liquids, I said that the viscous force is due to the cohesive forces between the liquid molecules. In case of gases, viscous force is due to the collisions. Okay, whenever they are colliding with each other, at that time they will exchange the momentum, means momentum will be changes. The momentum, Newton's second law states what? F is equals to delta P by delta T. Change the momentum by time only. Whenever they are exchanging the moment, nothing but they will have the force. That force is which force here? Viscous force. In case of gases. In case of liquids, the viscous force is due to which forces? Cohesive forces between the fluid molecules. Due to the cohesive forces. This is our force of viscous. Then in case of gases, the viscous force is due to which one? Collisions. Collisions between the gas molecules you have to take. By that collision what happens? Nothing but they will exchange the momentum. Nothing but momentum is changing. Momentum is changing means automatically they are gaining the force. Why? Because by the Newton's second law, F is equals to what is the formula? Delta P by delta T. Momentum is changing means they are acting upon a force. That is which force? Nothing but that is a viscous force here. Clear? So you have to mainly remember in the liquids due to the cohesive forces, in the gases due to the collisions between the gas molecules. Now how it will depends on the temperature, and then how it will depends on the pressure we will see. For example, if I say temperature, in case of liquids first of all we will discuss. You have to remember that due to the cohesive forces, viscous forces. Now how the temperature, how the viscous force is depending on the temperature we will see. Whenever I rise the temperature of the liquid, then what happens? You don't tell me about the viscosity directly, just tell me about the cohesive forces. Whenever I am rising the temperature, they will move away from each other, right? The water molecules will move away from each other. Whenever they are moving away from each other, at that time what happens? Cohesive force will decreases. For example, this is like charges only. Whenever I got two charges together, two unlike charges together, at that time what happens? Nothing but the force of attraction will be there in between them. Whenever I move them with a more distance, at that time what happens? Attractive force will decreases. In this case also the same thing only. Here whenever two water molecules are there near to each other, at that time what happens? Nothing but due to this much of smaller distance, the cohesive force will increases. Whenever I move away from each other, separation is more, then what happens? Force will get decreases. Whenever I raise the temperature, obviously the liquid gets expanded. Everybody know that. Whenever it is getting expanded means the distance between the molecules will increases. Distance is increasing means what happens? Cohesive force will decreases. Attraction force will decreases. Whenever two molecules are there near to each other, at that time they will have more force of attraction. They are moving away from each other, at that time they will have the less force of attraction. By raising the temperature, they will move away from each other. Whenever moving away from each other, at that time attraction will get decreases. Attraction is which attraction here? Cohesive force. Cohesive force is nothing but which force here? Viscous force. So whenever I raise the temperature, then what happens? Temperature rises. What happens? Separation will increases. Temperature rises, separation between the fluid molecules. Let me take, this is one molecule, this is another molecule. They are very near to each other. At that time what happens? Nothing but there will be more cohesive force. Whenever I raise the temperature, actually these two molecules will move away from each other. Whenever they are moving away from each other, then separation between them is increasing. Separation is increasing, nothing but the cohesive force will decreases. So that the cohesive force Fc will decreases. Fc is nothing but which one here? Viscous force only. So that viscous force also decreases only. Clear? You understand all the relation, right? So molecules are near to each other, more cohesive force. They will move away from each other, then less cohesive force. Why they are moving away from each other? Because I am raising the temperature. Whenever I raise the temperature, then liquid gets expanded. Whenever it is expanding means what? The separation is increasing. Separation increases, attraction decreases. That attraction is the cohesive force here. That cohesive force is nothing but the viscous force only. Now, whenever you come to the gases case, in the case of gases, whenever I raise gases, in case of gases, viscous force is due to which one? Due to the collisions between the gas molecules. Now, whenever I raise the temperature, then what happens? Collisions will increases or decreases? Increases. Collisions, number of collisions will increases. If collision is increasing, nothing but who is increasing here? Viscous force is increasing. Nothing but exchange of the momenta is increasing, so that viscous force is increasing. So, in case of liquids, by raising the temperature, viscous force will decreases. In case of gases, the viscous force will increases by rising of the temperature. Clear? Everybody understood, right? The temperature dependency is important. Next one is pressure. Whenever I increase the pressure, then what happens? So pressure, what happens? Pressure is increasing. Pressure nothing but this, in the case of gases, actually the viscous force is, in case of gases and then liquid, viscous force is independent of pressure. It will not depend on the pressure. But whenever I just increase the pressure, more pressure I am increasing, nothing but at that time what happens? Nothing but at one point of time, whenever I increase the pressure, if it is an incompressible liquid, whatever you might be increase the pressure, then what happens? Density will not changes. Incompressible and then compressible I said. Compressible nothing but what? Density changes. Incompressible means density does not changes. Whenever I increase the pressure also, I decrease the pressure also, in case of incompressible liquids, nothing will happen there. Why? Because density is not changing. Whenever I am rising the pressure more and more, at that time automatically what happens? Nothing but it will get compressed. Compressed nothing but fluid layers are moving near to each other. Near to each other nothing but more cohesive force or less cohesive force? More cohesive force. More cohesive force nothing but automatically more viscous force. In generally, the viscous force is independent of pressure. That is the main thing in case of liquids and then in case of gases also. But in case of liquids, one exceptional case is there, that is in case of liquids, whenever I raise the pressure more and more, I am just taking to the extreme pressure. The liquid is there under extreme pressure. At that time what happens? Nothing but they will move near to each other. Whenever the fluid layers are moving near to each other, at that time what happens? Cohesive force will increases. Cohesive force is increasing means automatically who is increasing here? Viscous force is increasing in case of liquids. But in case of gases, always this viscous force is independent of pressure, always, practically also. Clear? Liquids and then gases, actually they are independent of the pressure, but what happening nothing but in case of liquids, whenever I take under the extreme pressure, at that time what happens nothing but the fluid layers will move near to each other, then cohesive force increases, so that what will increase here? Viscous force also increases. Clear? Everything. So mainly in liquids the viscous force is due to which force? Cohesive force. In case of gases, due to collisions. By the collision what happens nothing but they will exchange the momentum. Momentum is changing, then force will be there. F is equals to delta P by delta T. Momentum is changing means force will be there. So that force is the viscous force here in case of gases. Clear, right? Yes, write that. Write a note point first. In case of liquids, the viscous force is mainly due to, in case of liquids, the viscous force is mainly due to cohesive force, mainly due to cohesive forces between the liquid molecules, in the next line. In case of gases, the viscous force is due to collisions between the gas molecules. Next, temperature dependency. Of viscosity. As the temperature raised, liquid molecules move. ಇದರ ನಿದ್ದೆ ಮಾಡ್ತಾ ಇದ್ವಾ? ಇಲ್ಲ, ಏನು ಡೀಪಾಗಿ ಸ್ಲೋಲಿ ಬರಿತಾ ಇದ್ದೀವಿ ನೋಟ್ಸು. What is it? When the temperature rise, liquid molecules moves away from each other, in bracket expansion. Then cohesive force of attraction between them decreases. Hence viscous force also decreases. Next one, in the next line, for gases, as the temperature rises, number of collisions increases. As a result, viscous force also increases. Next one, pressure dependency of viscous force. Right, in that viscous force is independent of pressure. In case of liquids and gases, in case of liquids and gases, but for liquids under extreme pressure molecules move near to each other, then viscous force increases. Viscous force will increases. Next one is Stokes law and terminal velocity. Stokes law, not Stokes law, Stokes law. Stokes law. So what Stokes law states means, first of all, for the section B people, force of buoyancy is not yet done for you. I will do in the evening study hours. I will take one extra class. Why? Because I have to balance here and then there. So I will take extra class and then I will do it for you. But the main thing is force of buoyancy means in which direction it will act? Any idea? Upward direction, right? Whenever you are just keeping some object in the water, nothing but on that upthrust force will be acting. That upthrust force is nothing but buoyant force. Okay, that you remember. And also the buoyant force formula is FB is equals to, what is the formula? V into rho into G. Let me take that is V dg. This is nothing but what? Density of which one? Density of liquid, and then this is a volume of the substance. That is the formula. Generally force is equals to mass into G only, right? mg only. Instead of mass, what will take? Nothing but rho into V. That's it. So that is the main thing you have to remember. Section B people mainly. Okay, already section A people know that. I hope so. At least formula you know, right? That's enough. Formula and then direction is enough. I am not asking about the problems. You are facing so much difficulty for solving of the buoyancy problems. That will be easy only, but you might be forgetting the logic there. Here volume nothing but which volume you have to take? Volume of the substance which is submerged in the liquid, and then here density of the liquid you have to take. So the main force of buoyancy nothing but the force of buoyancy or upthrust is exactly equals to the weight of the liquid displaced. That is the force of buoyancy. Main concept of the force of buoyancy is whenever you are just submerging one body in the liquid, at that time the force of buoyancy will act on that in which direction? Upward direction. That force of buoyancy is exactly equals to whenever you are just keeping something in the water, at that time what happens? Water will get displaced. So that force of buoyancy is equals to the weight of the liquid which is displaced. That weight of the liquid, how to get to know that? Nothing but you have to take it as a V into density into G. Here V is nothing but the volume of the body which is submerged in the liquid, and then here D is nothing but density of the liquid you have to take. That is about the force of buoyancy. But as per now, you just remember the formula and then just remember that in which direction it will act? In the upward direction. That is about the force of buoyancy. Now in the Stokes law, what Stokes stated nothing but, for example, if I take a liquid, I have taken a fluid, otherwise I have taken a fluid here. In that fluid, I am just dropping some spherical object. Dropping one spherical object of radius r, and then mass m. Radius is r. Then what happens? I am dropping it. It is having some weight already. So what happens? It will move downward direction. It is having more density than water obviously. So what happens? It will get sinked. It is getting sinked, nothing but what happening? It is moving in which direction? Downward direction. It is moving in the downward direction. Already downward who is acting? Weight is acting mg. And then upward who is acting? I said force of buoyancy, otherwise force of thrust is acting in the upward direction. Now I said that it is moving in the downward direction. So that acceleration is there in which direction? Downward direction. Now the main thing you have to remember is whenever this sphere is dropping towards, dropping through the water, otherwise it is moving through the water with some velocity. At that time what happens? Nothing but it will drag the fluid layers around it. What happens? These fluid layers will move like this, right? Whenever they are moving like this, at that time they will become near to each other. Near to each other, nothing but what happening here? Cohesive force is increasing. Cohesive force is increasing, so that which force will increase? Viscous force is increasing. Clear? So whenever the water drop, otherwise any spherical object, I just drop in the water column. Otherwise any oil column like that I have just dropped. Whenever I have dropped like that, it will move with some velocity in the downward direction. Whenever it is moving, obviously on that which force will act? Force of buoyancy will act in which direction? Upward direction. mg will act in the downward direction. It is moving with some velocity. Velocities keep on increasing. Why? Because it is coming in the downward direction. Any body which is moving in the downward direction, what happens in that? Velocity will increases. Velocity is increasing means I am taking the acceleration A. Now on that only force of viscosity also increases. Why? Because it is falling through the fluid. Whenever it is falling through the fluid, then fluid layers will move near to each other here. Like this, they will be just congested here, and then they will move near to each other. At that time, whenever they are moving near to each other, at that time cohesive force increases, so that which force increases here? Viscous force also increases. And viscous force is which force here? Frictional force. What it will do? Opposes the relative motion. Correct? So that it is that viscous force is opposing the relative motion. Opposing nothing but it will act in the upward direction. You understand the free body diagram here? Weight is acting already in which direction? Downward direction. Buoyant force is acting in which direction? Upward direction. Always it will act upward direction only. Now, as it is coming in the downward direction, viscous force will increases. That viscous force, how it will act? Nothing but it will opposes the relative motion here. So motion is there in which direction? Downward direction. Then viscous force will oppose nothing but it will act in which direction? Upward direction. Actually what Stokes states nothing but, the Stokes state that this, whenever I have taken the spherical object of radius r is moving through a liquid of coefficient of viscosity neta with velocity v, then on that a viscous force will act. That viscous force is exactly equals to Fv is equals to any idea about the formula? Yes, very good. 6 pi neta into r into v. That is a direct formula. Like however we got the viscous force formula A into dv by dy, in the same way that is Fv is equals to 6 pi neta r into v. Here neta is what here? Coefficient of viscosity of the fluid whichever we are in whichever we are dropping the object, and then r is nothing but what? Radius of the spherical object. Always spherical object only. I am not talking about the other objects, I am talking about the spherical object only. So that 6 pi neta is nothing but coefficient of viscosity, r is the radius of the spherical object, v is what? Velocity with which it is moving in the downward direction. So that is not only spherical object in the liquid, you can take that is a water drop also. Water drop will be there in which shape? Spherical shape. That is also falling through the air. From the sky it is falling through the air means it will attain the terminal velocity. What is that terminal velocity? I will tell. And then on that liquid drop also what is acting? Nothing but viscous force is acting. How much that viscous force will act here? 6 pi neta into r into v. Here air is also fluid only, obviously. I said that gases and then liquids are considered as water, fluids only. But the liquid properties will be different and then gas property will be different. So here any spherical object of radius r is just falling through the liquid column here. That liquid column is having how much coefficient of viscosity? Nothing but neta is the coefficient of viscosity. And that viscous force will act. How the viscous force will act? Why? Because viscous force is a friction between the layers only. Whenever it is falling through the viscous force, nothing, it is falling through the liquid, nothing but at that time viscous force will act on that. What viscous force will do? Oppose the motion of the body, otherwise oppose the motion of the fluid layers, so that it will oppose in this direction. Now that viscous force is exactly equals to how much? Nothing but 6 pi neta into r into v. That is a fixed value. So 6 pi neta into rv, here neta is the coefficient of viscosity, r is the radius of the spherical object, v is the with velocity it is falling through, that is the velocity v. That is about the viscous force. Now whenever you come to the terminal velocity means, instead of telling direct definition I will tell you the mechanism what happens. Whenever see this, here it is falling, you have to understand practically this one. Whenever the spherical object is, I have taken just an iron ball I have taken, I am just dropping in the oil, otherwise I am dropping in the honey. Whenever I drop in the honey, then what happens? Nothing but whenever it is going down, actually what happens due to the weight, what happens? Velocity will increases. Whenever I just take an object, I just dropped here. Drop nothing but initial velocity is how much? 0. Final velocity is how much? V is equals to under root 2gh. V is equals to striking velocity is always is equals to what? V is equals to under root 2gh. Whenever I am dropping the object from some height, then from some height nothing but h height I am dropping. Initial velocity is how much here? 0. But finally it is striking with some velocity. How much velocity? Nothing but V is equals to under root 2gh. How we got that? V square minus U square is equals to 2as. It is moving under gravity, so that g we will get. It is moving through a displacement how much? H height. So that V square minus U square is equals to 2gh we will get. What is the U value here? 0. Then V is equals to under root 2gh. Initially I dropped with what velocity? 0 velocity. Finally it is striking with what velocity? Under root 2gh. Nothing but velocity is increasing or not? Whenever the body is moving in the downward direction, due to the weight of the body, due to the gravitational force, then velocity will increases. So here velocity is keep on increasing. This spherical object is moving down, so that velocity is increasing. In the viscous force, I said viscous force proportionality relations. First of all, viscous force is directly proportional to what? Area of the fluid layers. Second one is what? Velocity gradient. Nothing but the viscous force is directly proportional to the velocity. Whenever the velocity increases, then automatically what will increases here? Viscous force also increases. I said clearly this one in the viscous force, it is directly proportional to the area, and also it is directly proportional to the velocity gradient. Nothing but velocity gradient means directly proportional to velocity only. Right? Whenever the velocity is increasing in the downward direction, then frictional force also increases. Initially what happens? Nothing but, can you tell me the equation for A here? I have written all the forces here. Tell me the equation for A. MA is equals to, for acceleration who is supporting here? Weight. W. Here these two are opposing. Minus FB and then minus FV. FB nothing but force of buoyancy, and then FV nothing but viscous force. This is the acceleration. When acceleration will come? Whenever the velocity is increasing, at that time acceleration will be there. Now what happening means, as it is moving in the downward direction, velocity will keep on increases. As the velocity increases, immediately what happens here? Viscous force also increases. But viscous force is which force here? Opposing force. My velocity is increasing in the downward direction only. At the same time, my viscous force also increasing. At some point of time, what happens means, this viscous force and then force of buoyancy together will balance with the weight. At that time, it will attain a constant velocity. Whenever constant velocity, then acceleration is equal to how much? 0. Now, here what I said nothing but, whenever it is, initially acceleration will be there. Initially in the fluid, acceleration will be there. Whenever it is keep on moving through the fluid, downward direction what will act here? Mg will act. Due to that mg, what happens means velocity will increases. Any body is moving in the downward direction, obviously velocity will increases. As the velocity increases, immediately who will increase here? Viscous force will increase. Viscous force nothing but which force here? Opposing force. Opposing force is increasing nothing but that is pulling in the opposite direction. Actually weight is there in the downward direction. Due to the weight it is moving down. Now what happening nothing but, for example, let me take this marker is there. This is moving down due to which force here? Mg. Due to mg, I just dropped it. I just dropped here and then it is coming with some velocity. So it is moving down and then velocity is keep on increasing. Whenever the velocity increases, resistance will increase here. Which resistance? Air resistance will increase. Air resistance is acting in which direction? Upward direction. So what happens means, in case of air, that will be less air resistance will be there. In case of liquid, any liquid I have taken means, downwards mg is acting. As the velocity increases, in the upward direction, viscous force is increasing. Mg is increasing, viscous force is increasing. At some point, already which force is acting in the upward direction? Buoyant force also acting. You just keep away that one. But first one you have to understand about the viscous force and then mg only. How the viscous force is increasing here? Why the viscous velocity? Whenever it is moving down, velocity is increasing. When the velocity increases, automatically viscous force also increases. But viscous force is acting in which direction? Upward direction. Mg is acting in which direction? Downward direction. At some point of time, the net force becomes 0. Why? Because it is keep on increasing. Initially it was less. As the velocity increases, viscous force also increases in the upward direction. Downward direction mg is acting. At some point of time, everything will get balanced. Equilibrium. Equilibrium nothing but acceleration becomes how much? 0. Why? Because net force is equals to 0 only. Acceleration 0 means what I can say? Velocity is constant. That velocity is known as a terminal velocity. It is falling only, however, with some velocity. With what velocity? Nothing but that is a terminal velocity. The terminal velocity is nothing but terminal velocity. What happening here? The viscous force and then buoyant force are balancing the mg. Net force is becoming as how much? 0. So only here ma is 0. Then what will get here? W is equals to W minus Fb is equals to what I can write? Fv I can write. Clear? This force of the viscous force equation we have to get. Viscous force is nothing but what? 6 pi neta r into v. This velocity is the terminal velocity. That terminal velocity value only you have to get to know. Clear? What is the terminal velocity? Understand? At some velocity what happens here? The net force becomes 0. Net force is become 0 nothing but all the downward forces equals to upward force. Net force is 0 means acceleration is 0. Acceleration 0 means velocity is what here? Constant. Acceleration 0 means velocity is constant only. So that is which velocity? Nothing but that is a terminal velocity. Whenever you see the raindrop also falling from the sky, from some kilometers of height only. Whenever, for example, if I say any object is falling from 10 meters of height, then what is the velocity you will get? It is falling in the air only with 10 meter height. How much you will get? V is equals to under root 2 into 10 only, under root 2gh. How much you will get here? 10 root 2 meter per second. Whenever it is falling only from 10 meters height only, it is moving with this much of velocity means, it is striking with this much of velocity means, the raindrop is falling from the sky, kilometers of height. With what velocity it has to hit? Nothing but it has to hit with kilometer per second only. In seconds time only it will fall from the sky. From the sky it is falling nothing but it is falling from some kilometers within the seconds only. So it has to hit us with more velocity. But it is not hitting. What is the reason? Nothing but whenever it is falling through the air is also fluid only. At that time what happens? Nothing but after some time what happens? Nothing but it will attain the terminal velocity. The terminal velocity is what here? Constant velocity. Whenever it is falling down, that velocity will decreases by which force? Nothing but here viscous force. Why? Because viscous force is acting in the upward direction. It is trying to move in the downward direction. So that what happens? Nothing but that velocity will get reduced by the viscous force and it will become constant at some point of time. That constant velocity is known as what? Terminal velocity. So only whenever the raindrop is hitting us, we are not getting hurted. That is the reason. Why? Because it is not falling directly, it is falling directly only, but on that viscous force is acting. Due to that viscous force, it is attaining which velocity? Terminal velocity. That terminal velocity is a constant velocity. Clear? That is about the terminal velocity. We will prove the formula also. Write that first. Stokes' law you write. Stokes' law states that when a spherical object is falling, not falling, is moving. When a spherical object is moving through a viscous liquid, of neta with a velocity v, due to the motion of the object in the fluid, there will be a viscous force, acts on that to oppose the relative motion. To oppose the relative motion. To oppose the relative motion. In the next line, the viscous force Fv is equals to. The viscous force Fv is equals to 6 pi neta Rv. 6 pi neta Rv. Fv is equals to 6 pi neta Rv. The next one, terminal velocity. Terminal velocity. Terminal velocity. As the object moves through the fluid, as the object moves through the fluid, its velocity increases due to the gravity first. Its velocity first increases due to the gravity. As the velocity increases, then viscous force also increases. Shreyas, good morning. బాగున్నారా? బాగాలేరా? What I said? Shreyas, good morning. Viscous force also increases. At some instant, the net force becomes zero. Net force becomes zero. Means acceleration is zero. Hence velocity is constant. Comma, this constant velocity is known as terminal velocity. This constant velocity is known as terminal velocity. Draw this diagram first. ಯಾರೋ ತುಂಬ ಡೀಪ್ ನಿದ್ದೆ ಮಾಡ್ತಾ ಇದ್ದಾರಪ್ಪ. ಟಿಜಿನಾ? ನಿದ್ದೆ ಮಾಡಬೇಡ್ರಿ, ಡಯಾಗ್ರಾಮ್ ಡ್ರಾ ಮಾಡಿರಿ. ಏನು ಉದಯ್, ಏನಂತ ಇದ್ರಿ ನಿಮ್ಮ ಶ್ರೀವಲ್ಲಿ? ಡ್ಯಾನ್ಸ್ ಮಾಡಿದ್ರಾ ನೈಟು? ಪ್ರಕಾಶ್ ಸರ್ ಮೊಬೈಲ್ ಇಟ್ಸ್ಕೊಂಡು ಏನು ನೋಡಿದ್ರು? ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರಾ ಶ್ರೀವಲ್ಲಿ ಸ್ಟೆಪ್ಪು? ರೈಟ್, ನಾಳೆ ಅಪ್ಲೋಡ್ ಮಾಡಬೇಕಾ? ಅಲ್ಲು ಅರ್ಜುನ್ಕಂತ ಇವರೇ ಫೇಮಸ್ ಆಗ್ತಾರೆ. Now the force of viscosity, viscous force is equals, what is the formula viscous force? By the Stokes law, what is the formula? 6 pi neta into R into V. What is the neta there? Coefficient of viscosity of the liquid or fluid, whatever we have taken. R is what? Radius of the object, spherical object. V is the velocity. In this case, which velocity that is? Terminal velocity. It is attaining the terminal velocity, right? So the terminal velocity you have to take. Now the viscous force formula we will write later. First of all, weight is equals to, what is the formula? mg minus force of buoyancy is what? V into rho into g. I will take here the liquid of sigma is the density and the object of rho is the density. Clear? Now what I can write, nothing but this is force of buoyancy, nothing but we know that V into, what is the density here? Sigma. Sigma into g. Actually V rho g will take. V is the volume of the substance and then rho is nothing but what? Density of the fluid. In this case, what is the density of fluid here? Sigma. The force of buoyancy formula is for us volume of substance and then density of fluid and then into g. That is the formula for us. Now here volume of substance is what? Volume of the spherical object you have to consider, and then density of the fluid is what I consider here? Sigma. Density of the object is how much? Rho, and then into g is as it is. Now mass, nothing but instead of mass what I can write again? V into, what is the density of the object here? Rho is the density of object and then minus g is equals to V sigma g. From this what I can take common? Yes, GV, RGV I can take common. GV is common, then rho minus sigma. Who is RGV? No? RGV is like you only, same. Yes, he is like you, very good person. Now volume is equals to, what is the formula? 4 by 3 pi into R cube into G you have to take, then this is what? Rho minus sigma. Clear? Then what is the viscous force means? By the Stokes law? 6 pi neta I into R into V. 6 pi neta R into V. Which velocity here? Terminal velocity. That is what I have to derive here. Now what will get cancelled here? Pi gets cancelled. R also gets cancelled. Then what is remaining here? This is 3 and then this is 2. Then terminal velocity Vt is equals to what I can write? 2 by 9 into R square into G into rho minus sigma divided by what is remaining here? Neta. That much of big formula you have to remember. 2 by 9 R square G into rho minus sigma by G. Clear? Now listen again. As this is falling through a fluid of density is how much? Density of the fluid is how much? Sigma. Density of the object is how much? Rho is the density. If they have given mass, that is very good enough. Directly we can substitute here mg and then we will get the answer there. Clear? But they will not give the mass, they will give the volume only. They will give the radius of the object only. So that it has to fall through the fluid of the density is how much? Nothing but here sigma is the density, and then whenever it is moving down, at that time its velocity will keep on increases. As the velocity increases, which force will increases here? Viscous force will increases. That viscous force and then force of buoyancy will balance with the weight. At that time what happens? Net force becomes 0. Net force becomes 0 means acceleration also becomes 0. Acceleration 0, then velocity is equals to constant. That constant velocity is known as which velocity? Terminal velocity. That is what you have to derive first of all. Now I said that the acceleration is become 0, nothing but this entire thing is 0. Then what is remaining for us? Fv is equals to V minus W minus Fb. W nothing but what? Weight of the object. Fb is what? Force of buoyancy. What is the force of buoyancy? Volume of the substance, density of the liquid, and then G you have to take. Now the Fv is equals to W minus Fb. W nothing but mg minus force of buoyancy is volume of the substance is V, density of the liquid is sigma, and then G as it is I have written here. V sigma G is the force of buoyancy. And then here mass is nothing but what? Mass already you know that. Volume into density only. Volume of the object is how much I have taken that as V, and then density of the object is how much? Rho. So that V rho G minus V sigma G. From that Vg I have taken common. Then what is remaining here? Rho minus sigma. Rho is nothing but what here? What is the rho? Density of object, spherical object. Sigma is nothing but what? Density of the fluid. So that rho minus sigma. Now in that G as it is there, V nothing but, because the spherical object is falling here, what is the volume of the spherical object? 4 by 3 pi r cube, everybody know that. And also the viscous force formula is 6 pi neta into RV. So that in that pi gets cancelled, everything gets cancelled here. What is remaining? Nothing but the terminal velocity Vt is equals to 2 by 9 into r square G into rho minus sigma by neta. That is important formula, terminal velocity formula. Clear? Copy that, everything you copy. In the diagram again you indicate the sigma and then rho. Write the force of buoyancy formula also. Time ಆಯಿತು ಆಲ್ರೆಡಿ, ಒಂದು 5 minutes ಅಷ್ಟೇ. I understand. You are facing so much difficulties to sit, right? Combined class means. ನೀವು ವಿಂಡೋ ಪಕ್ಕನೇ ಇದ್ರೆ ನಿಮಗೆ ಡಿಫಿಕಲ್ಟಿ, ನಮ್ಮ ಈ ಥರ ಅಂತ ಇದ್ರು ಪಾಪ ಇವ್ರಿಗೆ ತುಂಬ ಕಷ್ಟ ಆಗುತ್ತೆ, ಇವ್ರಿಗೆ ಅಂದರೆ ನಾ ಲಾಸ್ಟ್ ಪೀಪಲ್ಗೆ ಕೂಡ. ಕ್ಯಾರೆ 4 to 5 AC, then 4 to 5 lakhs तू पे कर पहले. 4 to 5 AC ಇಟ್ಟಿದ್ರೆ ಕೂಡ ಆಗಲ್ಲ. However, they will not work, no. Already 3 AC are there. ಏನು ಡಿ ಬಾಸ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಫನ್. ಬರ್ಡೇನಾ ಯಾವಾಗ? February 16th, February 14th? ಏನು ಹರ್ಷ ನೀವಲ್ಲ? ಯಾಕೆ February 14 ಇಸ್ ವ್ಯಾಲೆಂಟೈನ್ ಡೇ ಫಾರ್ ಎವ್ರಿಬಡಿ, ಯಾಕೆ ನಿಮಗೆಲ್ಲ ಬ್ಲ್ಯಾಕ್ ಡೇನಾ? ಯಾಕೆ ಲವ್ ಫೇಲ್ಯೂರಾ? ಲವೇ ಮಾಡಲ್ಲ? ಎನಿ ಪ್ರಾಬ್ಲಮ್? ನಥಿಂಗ್ ರೈಟ್? ಲವ್ ಮಾಡಬೇಕಪ್ಪ, ಲವ್ ಮಾಡಬೇಕು, ಬ್ರೇಕಪ್ ಆಗಬೇಕು, ಎಲ್ಲ ಆಗಬೇಕು ಲೈಫಲ್ಲಿ. ನೋ, ವಾಟ್ ಇಸ್ ದಟ್? ಶ್ರೀವಲ್ಲಿ ಬರಬೇಕು, ಶ್ರೀವಲ್ಲಿ ಹೋಗಬೇಕು, ಮತ್ತೆ ಸಾಮಿ ಸಾಮಿ ಅನ್ಬೇಕು. Next, critical velocity. So terminal velocity we got. What is the terminal velocity means? The definition is not necessary, by the way. Why? Because you cannot say that terminal velocity is nothing but constant velocity. At which what happens? That at that constant velocity what happens? Net force becomes 0. Net force becomes 0, so that force of buoyancy and then viscous force will balance with the weight of the spherical object we have taken. So net force, how much we got? 0. From that we got the terminal velocity formula. Terminal velocity is 2 by 9 r square G into rho minus sigma by neta. Here rho is what? Density of the object, and then sigma is what? Density of the fluid, and then neta is the coefficient of viscosity, r is the radius of the object, and then G is the gravity. You just indicate this one, otherwise you will get confused. Here you indicated in the diagram, in the notes. You don't forget that. Next, critical velocity. Critical velocity means completely different. Till here everything is finished. Next, critical velocity and then Reynolds number will be there. After that too, we can finish this one. Whatever the dynamics we got, after that we will get the surface tension. Only 3 topics are there: surface tension, surface energy, and then capillarity. In that capillarity only you will get the excess pressure. Okay, that we will discuss and then we will close this chapter. But it will take 2-3 days time at least. So for that, critical velocity. What is the meaning of critical velocity means? You remember about the streamline flow and then turbulent flow. What is the streamline flow? Nothing but all the streams will be parallel to each other. Turbulent, nothing but what happens? They will be in the zigzag manner. And then we got the rotational and then irrotational, and then compressible and then incompressible and all. So first of all, streamline flow will be there. Water will be flowing with some velocity. whenever they are flowing with some velocity, at that time what happens? Nothing but whenever the water is flowing in the downward direction, at that time what happens? Velocity will increases. The velocity will increases and it will reach to some velocity known as the critical velocity. After that limit, what happens means the streamline flow will become as a turbulent flow. You understand? Initially they are moving parallel to each other. For example, Q is there, 4 Qs are there parallel to each other. They are already walking, okay, then they are walking, then they have given some pulihogra packet. Otherwise for Shivu they have given 2 bottles. They have shown 2 bottles like this, they have lifted like this. At that time what happens? Nothing but the whatever the Q was there, that became zigzag. Before it was which flow? Streamline flow. Whenever he see the bottle, at that time what happening? It is becoming as a turbulent flow. He was running for the bottles and the remaining people don't know for what he is running, and then they will also running only. And then for Uday, Srivalli will be there. However, because of Srivalli, he will be running there. So whatever the reason might be, they will have their individual reasons, but velocity increases. At some velocity what happens? What happens? Streamline flow will become as a turbulent flow. That velocity is known as the critical velocity. Actually that is a limit. Okay. So V is the velocity here. This critical velocity is the limit. Critical velocity is the limit. Before the critical velocity, what is the flow? Streamline flow. After the critical velocity, which flow? That is turbulent flow. That's it. So the main thing is critical velocity means the velocity up to which the flow will be streamlined. Once it is crossing the critical velocity, what happens? The flow will become turbulent flow. Turbulent flow nothing but zigzag flow will be there. Streamline nothing but all the streams will be parallel to each other. Clear? That is about the critical velocity. And then this critical velocity also depends on some things. That is, for example, I have taken the pipe here. Pipe of diameter D. Diameter of the pipe is small d or capital D, anything you can take. And then in this, the fluid is flowing. Of coefficient of viscosity is how much? Nothing but neta. Now this critical velocity, how it will depends on this neta and then this density. How it will depends? Nothing but the critical velocity is directly proportional to the neta, coefficient of viscosity, and the critical velocity is inversely proportional to the density, not density, amma talli, amma tayi yaramma avaru, diameter. So Vc is equals to what is the formula you will get? Neta by d. One more thing will be there. It will depends on one more thing. What is that? Density na? Yes, very good. Density of the fluid. It will depends on the density of the fluid. If the density is more, nothing but velocity will decreases rate automatically. So that it is inversely proportional to the density. So what will get here? Vc is equals to neta by density into the diameter. So what is that? Directly proportional to neta, inversely. No, it is inversely only. Whenever the area increases, obviously by the Bernoulli's theorem only you know that, equation of continuity. Area increases, then what happens? Velocity will decreases. So that velocity is inversely proportional to the diameter here. Now Vc is equals to neta by d into rho. Now directly proportional here. Then Vc is equals to, this can be removed by a constant known as the Reynolds number. Re, Reynolds number, that is neta divided by d into rho. That is the critical velocity. Okay, don't work hard ma last. ಏನಮ್ಮ ಹೆಸರು ನಿಮ್ಮದು? ನಿಮ್ಗೆ ಅಷ್ಟು ಪ್ರಾಬ್ಲಮ್ ಇದೆ ಅಂದರೆ ಫಸ್ಟ್ ಬೆಂಚ್ಗೆ ಬರಬೇಕಮ್ಮ ನೀವು. ಸ್ವಲ್ಪ ಜನಕ್ಕೆ God will give height unnecessarily. Like Samantha Mani. What he will do with that much height? For some people like me, he will not give the height. It will be less only. Now here, how sad, no? How sad. Now critical velocity. Critical velocity is nothing but up to which the flow will be which flow? Up to critical velocity, streamline flow. After the critical velocity, turbulent flow. That is the critical velocity. That is the just limit. Just before that streamline, and then after that it will be turbulent. Now this critical velocity will depends on some things, that is coefficient of viscosity directly proportional to the coefficient of viscosity and inversely proportional to the density of the fluid whichever we have taken, and also inversely proportional to the diameter. Whenever it is becoming as more denser, at that time what happening, nothing but velocity will decreases obviously. And also whenever the pipe area is increasing, at that time also what happens, velocity will decreases only. By the equation of continuity we know that A is inversely proportional to V. What is the formula of the equation of continuity? AV is equals to constant. So A is inversely proportional to the V. Area increases, then velocity will decreases. Now whenever I see this critical velocity directly proportional to neta, inversely proportional to the density, then and also inversely proportional to the diameter, then Vc is directly proportional to what I can write all together, neta divided by rho into d. Then this proportionality is removed by a constant known as a Reynolds number. So that Reynolds number is Re. What this Reynolds number will do, nothing but it will give the idea about the flow of the liquid. Nothing but by using the Reynolds number only we can say that flow is a laminar flow, na, otherwise nothing but streamline flow, na, otherwise turbulent flow, na. Okay, whenever the Reynolds number is less, at that time what happens, Reynolds number is less, nothing but critical velocity also less only. Less velocity, nothing but which flow, that is streamline flow. If Reynolds number is more, at that time the flow will be turbulent flow. If the Reynolds number is between the 1000 to 2000, at that time the flow is the unsteady flow. What do you mean by steady flow and then unsteady flow? I said already. For the steady flow, what happens, nothing but at one point the velocity will be same. For all the molecules, whoever are crossing that point will have the same velocity. Unsteady, nothing but different velocity will be there. Clear? That will Reynolds number will give the idea about the flow. Which flow is that? We will discuss about that. First of all, write this critical velocity. The velocity up to which the velocity up to which the velocity up to which the fluid flow is velocity up to which the fluid flow is streamlined. After that it will become turbulent. After that it will become turbulent. In the next line you write, this critical velocity is directly proportional to coefficient of viscosity neta, coefficient of viscosity neta. In the next line, inversely proportional to density of the fluid and also inversely proportional to diameter of the pipe, and also inversely proportional to diameter of the pipe. The next line, the proportionality of the critical velocity will be removed by a constant known as Reynolds number. In my childhood, one pen was there, Reynolds. Now also there, I am saying like I am from the other Janma only. Reynolds number. Last one we'll see. Last one Reynolds number we'll see. See here. Enagala tarri solpa. Enu Uday? ಹೋಗಬೇಕಾ ಅರ್ಜೆಂಟಾ? So Vc is a critical velocity here. Critical velocity is nothing but Re neta by d into rho. What is the d here? Diameter, and then rho is what? Density of the fluid. Now here Re is equals to what I can write? See that? Re is equals to Vc into d rho by neta. I will tell you something we will do with for remembering this one definition of the Reynolds number. For that, first of all, here Vc d rho by neta is there. For us actually what is the Reynolds number formula nothing but that is a force by inertial forces divided by the viscous force we will get. So I will get the inertial forces and all. For example, you know the viscous force formula. What is the viscous force formula? No, first basic formula, that is area into dV by dy only. What is the formula? Neta into A into dV by dy. I can take this as V by length only. I can take it as a length. Now what I am doing nothing but here, Vc, how I can take that one? As Reynolds number is nothing but the force divided by the viscous forces. How can you get that? In the denominator what we are having only? V is there, right? For us neta is there, right? So you have to get the V and then L and then A. And also force formula, in case of fluids we will use the force formula is rho A V square. You know that? You might be solving the problems also. F is equals to what is the formula? Rho A into V square you will get. So already rho is there. To get the area what I will do nothing but I will multiply with area and then divide with area. Now I have to get rho A V square. Here only one velocity is there for us. I have to get another velocity. What I can do here? Into V and then divided by V I will do. Now rho A V square is finished here. Rho A V square is finished. Next what is remaining here? Neta A is remaining, that divided by V, this diameter I will get here. Neta A into V by D. So this is which force down? Viscous force. On the top which force nothing but that is a force. We will take that force is known as a inertial force. Okay, the Reynolds number is the ratio of inertial force to the viscous force. How we got nothing but somehow we got this formula. This is a Reynolds number, this is a inertial forces. Inertial force to the viscous force. How we got nothing but here Reynolds number is equals to V D rho by neta. Here neta I have to get nothing but in terms of viscous force what is the formula? Neta A into V by L. Velocity by length you have to get, that is the velocity gradient. And then you have to get the rho A V square on the numerator. For that what I am doing nothing but I am multiplying with A, dividing with A, multiplying with velocity and then dividing with velocity. Rho A V square gives you what? Force. Which force nothing but inertial force. That divided by neta A into V by the distance is known as what? Viscous force. So you just remember this is enough. This one is enough. But how to remember that nothing but the formula, how to remember nothing but the Reynolds number is nothing but the ratio of inertial force to the viscous forces. So the final formula is already you know the critical velocity relations. If you remember these relations, then you can get the Reynolds number and then critical velocity, both the formulas. If you know the viscosity relation, Fe is directly proportional to A, Fe is directly proportional to the velocity gradient. Then we can get the viscosity formula. What is that? Fe is equals to neta into A into dV by dy. Always you cannot remember the final answer, but you remember the relations, that's it, you will get the answer there. Now the critical velocity already you know that Vc is directly proportional to neta, inversely proportional to the density of the fluid and also inversely proportional to the diameter of the pipe. From that we remove the proportionality and then we got a constant known as what? Reynolds number. That Reynolds number what it will do nothing but it will give the idea about the fluid flow. If the Reynolds number is between these values what happens, less than that value what happens, more than that value means what happens. That will give the idea about the fluid flow. Now in this first of all you have to get to know what is the Reynolds number means. The Reynolds number means the ratio of inertial forces to the viscous forces. From here only we can get the Reynolds number formula, that is Vc into dg by neta. This one is not necessary. This one is not necessary. To prove the definition I said this one. Clear? Now the Reynolds number nothing but the ratio of inertial forces to the viscous force. I said the value lies between some values. So here if the Reynolds number is less than 1000, less value nothing but which flow I said? Reynolds number less means automatically critical velocity also less only. Which flow I said? Streamline flow. Streamline flow or laminar flow. Everything is same only. Laminar or streamline nothing but all the streams will move parallel to each other. Now whenever the Reynolds number is greater than 2000, at that time flow will be which flow? Turbulent flow. If the Reynolds number is lying between, it is lying between 1000 to 2000, nothing but in between that values, that will be which flow? That is unsteady flow. Unsteady nothing but the velocity at each and every point will be varying only. Clear? That is about the Reynolds number. Right there. First of all, you copied this one. Copy this one. Along with the diagram also you have to copy. Next, write that Reynolds number. Reynolds number. Reynolds number. The ratio of inertial forces. The ratio of inertial forces to the viscous force. The ratio of inertial forces to the viscous forces. Write that formula. RE is equals to VC d rho by neta. Write that formula also. F inertial divided by F viscous also. Okay.